Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the problems on vector integration, and the problems has been taken from question bank from module 5, and it is from part A and the second video. And now we will see some problems and we solve the problems now itself. And see the problems, the problems comes from vector integration. In vectors there are two topics. One is vector differentiation and vector integration. And the given problem is, if f bar is equal to 2x plus y square into I bar plus 3y minus 4x into j bar, evaluate integral f bar dot dr bar around a triangle ABC in the xy plane with the vertices a0, 0, b2, 0, c2, 1 in the counterclockwise direction. So what you have to evaluate? Integral f bar d dot dr bar around the triangle ABC. So first write the given vector point function. Given f bar is equal to 2x plus y square into I bar plus 3y minus 4x into j bar. Clearly there is no k bar term because the complete f bar is defined in xy plane. And now we have to calculate f bar dot dr bar integration. And what is dr bar? Dr bar is nothing but dxi bar plus dyj bar plus dz k bar. Then f bar dot dr bar is equal to 2x plus y square of dx plus 3y minus 4x into dy, and z term clearly 0, so there is no z term in this. Now we have to consider the integration along f bar dot dr bar along the closed curve C. So the curve C is the triangle ABC. Clearly, suppose if you write in the Cartesian system x-axis, y-axis, and what are the vertices? a0, 0 is 1 point, and b2, 0, that will be also on the xy plane, b2, 0, and other point is c2, 1, this is 2, c2, 1, y1, this is the point 2, 1, c2, 1, this is the point. Now the triangle will be in this is the triangle. So here we have to evaluate the integral f bar dot dr bar along the triangle, that means along BC, AB, along BC plus along CA, because it is, the direction is the counterclockwise direction, that is anti-clockwise direction, that is first AB along, then BC along CA, that will be along the triangle ABC. So what I can write is integral around the closed curve C f bar dot dr bar can be written as integral f bar dot dr bar along AB plus integral along BC plus integral along CA. F bar dot dr bar along AB, along BC, along CA. Now what is the equation of AB? Now we will show that. Integral first f bar dot dr bar already we have calculated. Now integral f bar dot dr bar along AB, that is equal to integral along AB. What is the function given? 2x plus y square, 2x plus y square of dx plus 3y minus 4x, 3y minus 4x of dy. So here what is along AB? So here just I will write again, A0, 0 is one vertex and B2, 0 is the other vertex and C2, 1, C2, 1 is the other vertex. So this is formed as a triangle AB along, so I will show this. along AB, along BC, along CA. So what is along AB? This is x-axis, this is y-axis. Along AB, what is the equation? Along AB means, along AB, what is the equation of AB? The equation of AB x-axis, y is equal to 0. The equation of AB is y is equal to 0 because it is x-axis. Then dy also 0. Y 0, dy 0. But here x is a variable. X varies from 0 to 2. Here x varies from 0 to 2. Therefore, what it becomes? This is equal to integral x varies from 0 to 2. 2 into x variable, y constant 0 and dx is variable plus here dy 0. Dy 0 means the entire term 0. So we'll get integral 0 to 2 2x dx. So I'm taking along AB. The equation of AB is y is equal to 0 because it is x-axis. If y 0, then dy also 0. But here x is a variable. X is initially it is 0. So as move on to this direction, it becomes up to 2 only. So x varies from 0 to 2. So dy 0 means entire second term fully 0. And y also 0. This is also 0. Only you get 2x dx. That is 2x square by 2 between 0 and 2. So this value is equal to 4 minus 0. That is equal to 4. That is the first integral along AB. Now we have to find along BC. Along BC. What is the equation of BC? This is x is equal to 2 line. This is y is equal to 0 line. This is x is equal to 2 line. And what is this line? Here x-intercept is, what is y is equal to mx format? Y is equal to mx format. So I can write, or you can write x by x-intercept 0 and y-intercept is y-intercept is 0, or I can write this is y is equal to mx. So what is slope is y2, this is calculating this line equation. So this is the slope between 0, 0 and 2, 1. So the points, then what is y2 minus y1 formula by x2 minus x1. That is y2 minus y1, 1 minus 0 by x2 minus x1, 2 minus 0. That is equal to 1 by 2. Or y is equal to 1 by 2 into x. Or x is equal to 2y. That is the line x is equal to 2y. So first observe this triangle. This is the line y is equal to 0. This is the line x is equal to 2 because it is passing through 2, 0 and perpendicular to x-axis. And this is the line x is equal to 2y, or y is equal to 1 by 2 into x. So along AB already we have calculated. Now I am going to along BC. Along BC. Second one, along BC, integral f bar dot dr bar along BC is equal to integral, what is the function? 2x plus y square of dx plus 3y minus 4x of dy along AB. Here the equation is x is equal to 2. Equation of BC is x is equal to 2. Then dx is equal to 0. But y is a variable factor. Y is a variable factor from 0 to 1. Y varies from 0 to 1. Therefore, this is equal to, what you will get, dx 0 means first term, entire term 0. Whatever this is, here 3 into y minus 4 into x is 2. 4 2 into dy. The limits are y varies from 0 to 1. That is integral 0 to 1, 3y minus 8 of dy. So on integrating, what you will get? 3y square by 2 minus 8y between the limits of 0 and 1. 3 by 2 minus 8 minus 0 plus 0. Or 3 minus 16 by 2 It is equal to minus 13 by 2. This is the second integral evaluation along BC. So this is 0 to 1. Y varies from 0 to 1 because we are considering the direction also. So y varies from 0 to 1, and on substituting the function and substituting the values, you will get this. Now, the third one, along CA. The equation of CA is x is equal to 2y. The equation of CA. What is that? CA. This is CA. CA. The x is equal to 2y. Then what you will get? Dx is equal to 2 dy. Now, integral f bar dot dr bar along CA is equal to integral along CA. So, what is the function? 2x plus y square of dx plus 3y minus 4x of dy. Or I can write this as integral. CA means along. Suppose if you consider all y terms, y varies from 1 to 0. Y varies from 1 to 0. And here 2 into x is 2y. X is equal to y. And y square remains same. Dx is equal to 2 dy. Plus 3y remains same, minus 4 into x is 2y, and what is dy? Dy is remains same. It is integral 1 to 0, 4 to 8y first term, plus 2y square second term, plus 3y third term, minus 8y, and it is a dy. Minus 8y plus 8y cancel. Integral 1 to 0, 2y square plus 3y dy. So what is the integration? 2y cube by 3 plus 3y square by 2 between 1 and 0. So on substituting the upper limit, both terms are zeros. Lower limits 2 by 3 minus 3 by 2. On putting y for 1, 2 by 3 minus y for 1, 3 by 2. So LCM 6, 3 2's minus 4, 3 2's, 2 2's, 2 3's, 3 3's, right? Minus 13 by 6. This is the third integral. Therefore, integral along the triangle ABC. Therefore, integral along the triangle ABC, f bar dot dr bar is equal to. So, I'll add all the three values. First value 4. Minus 13 by 2, minus 13 by 6. 4 minus 13 by 2 minus, this is minus 13 by 2, and it is minus 13 by 6. That is 6 LCM. 1 6 4s are 24, 2 3s 39, minus 13. That is 24 minus 52 by 6. That is equal to, what is the value? 8 minus 28 by 6. So this is the required line integral along the triangle ABC. Now see the second problem. Using Green's theorem, evaluate integral over C 3x square minus 8y square dx plus 4y minus 6xy dy, where C is the region bounded by y is equal to x square and y is equal to root x. So it is the only application problem. It is not the verification problem. So we know that by Green's theorem, integral over the closed curve C m dx plus n dy is equal to double integral over region R dou n by dou x minus dou m by dou y dx dy, where R is the region bounded in xy plane. This is x plane, this is y, xy, x axis, y axis, this is all xy plane, and it is the region. This region is capital R, and it is bounded by a simple closed curve C, and M and N are continuous partial derivatives defined on this one. Then what is integral over the closed curve C? M dx plus N dy is equal to double integral over R dou N by dou x minus dou M by dou y dx dy. Now what we have to do is we have to use Green's theorem to evaluate this one. So what is to evaluate integral M dx plus N dy over the closed curve C? We can replace by double integral over R dou N by dou x minus dou M by dou y dx into dy. And what is the reason here? Y is equal to x square and y is equal to root x. Y is equal to x square means it is a parabola. It is a parabola. And y is equal to root x. And this is y square is equal to x. This is also a parabola. This is symmetrical about y axis. Y axis symmetrical. This is x axis symmetrical. Y axis symmetrical. One is like this. And other one is like this. So the area bounded in between the two parabolas. I will show in complete figure what this is. Y square is equal to x, or y is equal to root x. And what is the other curve? X square is equal to y, the intersection point 0, 0. And other one is 1, 1. When you solve the two equations, x square is equal to y, you can see here, y is equal to x square, y is equal to root x. Y is equal to x square and y is equal to root x. So in solving the two equations, x square is equal to root x, or x power 4 is equal to x, or x power 4 minus x 0, x into x cube minus 1 0. So x is equal to 0 is one equation. This is a cube minus b cube. So a minus b, x minus 1 0. So x is equal to 1 also. Other root is the complex roots. So those roots are need not to consider. So these are the intersection points. 0, 0 is 1 point and 1, 1. And the region is like this. And we have to take the strip inside the region parallel to y-axis or parallel to x-axis. On taking the strip parallel to y-axis, the lower strip of the edge is on the curve y is equal to x square. So y is equal to x square is the lower limit. And what is the upper limit? This upper limit is on the curve x is equal to y square, or y is equal to root x. Y is equal to root x. And x varies from here 0 to 1. Therefore, double integral over the closed curve C, I will tell you, over the curve C, 3x square minus 8y square of dx plus 4y minus 6xy dy is equal to cosine. Now we have to apply the Green's theorem to evaluate this. Integral m dx plus n dy, it looks like. Here what is m? M is equal to 3x square minus 8y square. And what is n? 4y minus 6xy. Then what is dou m by dou y? That is minus 16y. And what is dou n by dou x? Minus 6y. Dou n by dou x. This is 0 and minus 6y. Then what is the value? By Green's theorem, integral m dx plus n dy is equal to, over the closed curve C, double integral dou n by dou x minus dou m by dou y dx dy over the region R. So this integral becomes double integral dou n by dou x minus 6y and minus now minus plus 16y dx dy over the region capital R. The line integral is shifted to the double integral by using Green's theorem, and the region area is bounded between the two parabolas y is equal to x square and y is equal to root x. So that the limits for integration, what here limits for integration? Already I have written y is equal to x square to root x, and x varies from 0 to 1. X varies from 0 to 1. The 16y minus 6y, the value will become the 10y. First has to be integrated with respect to y, then with respect to dx. Now the problem is picturized into double integral, that is integral 0 to 1, integral x square to root x 10y dx dy. So because y limit is a variable limit, we have to integrate the function first with respect to y. So in integrating, what you will get? Integral 0 to 1 as it is, and 10 y square by 2. What are the upper limits? X square to root x. X square to root x of dx. That is 2 5s, 5 constant, 0 to 1, upper limit root x whole square. That is x, this is x power 4 of dx. Y square, upper limit root x whole square, x square whole square, x power 4 dx. Now what is the integration for x dx? The value is x square by 2, and for x power 4, this is x power 5 by 5 between 0 and 1, or 5 into 1 by 2 minus 1 by 5 minus 0 minus 0. Both are lower limits are 0. So that is 5 into, what is LCM? 10. 2 5s, 5 1s, 5 2s, 2 1s. So this is 5 into 3 by 10, or 3 by 2 is the required double integral value. 5 2s are 10. The required solution is 3 by 2. So here, just we have converted the line integral into double integral by using Green's theorem. The Green's theorem states that integral over the closed curve C, mdx plus mdy is equal to double integral dou n by dou x minus dou m by dou y of dx dy. Here the region limits you can calculate easily. First you have to identify the curves. Both are parabolas. Because the parabolas, the area will be the intersection of the two parabolas. So there ends the second problem. The answer we got is 3 by 2. No answer we will verify. Now the third problem is Gauss divergence theorem. Using Gauss divergence theorem, evaluate integral f bar ds, where f bar is equal to the vector y I bar plus x j bar plus z square k bar for the cylinder region S given by x square plus y square is equal to a square, and z is equal to 0 to z is equal to b. The region of integration is three-way: x-axis, y-axis, z-axis, and the base is the circle. The base is the circle in xy plane. So the radius is equal to a. So the equation of this is x square plus y square is equal to a square. The lower base is the circle. The circle equation given by x square plus y square is equal to a square. So I can show this as the radius a units, and the circle is x square plus y square is equal to a square. And z is equal to 0 to z is equal to b. Z is equal to 0 means what? This xy plane compared z is equal to 0. Base plane, that is z is equal to 0. To upper limit, z is equal to b. This is z is equal to b plane. So this is the region of integration. The region of integration is the cylinder. Already given the cylinder. This is looking like cylinder. It is looking like this, and this. This is like a cylinder. And the limits for z is equal to 0 to z is equal to b. These are the height limits. And area limits is the circle area limits. That we'll discuss later. And what is here we have to calculate is integral f bar dot ds bar. You have to calculate. That is integral f bar dot ds bar. I can write integral f bar dot ds bar. I can write integral over v div f bar into dv. That means what you have to evaluate is first div f bar. So f bar, what is f bar? X. I will write given. What is f bar? yi bar plus xj bar plus z square into k bar. Z square into k bar. Then div f bar, that is del cross f bar, that is determinant of I bar, j bar, k bar, and dou by dou x, dou by dou y, dou by dou z. And what is the third row? This is y, this is x, and this is z square. Because the terms are y coefficients x, z square. So I bar into dou by dou y of this one 0 minus 0 minus j bar into dou by dou x of z 0 minus 0 plus k bar into dou by dou x of x 1 minus dou by dou y of y 1, that is 0. So this is z square, I think. This is dou by dou y of z square. We have to evaluate using the Gauss divergence theorem, integral div f bar, not curly f bar. So I have calculated curly f bar. Div f bar means what? Del dot f bar. That is I bar dou by dou x plus y bar dou by dou y plus k bar dou by dou z dot f bar yi bar plus xj bar plus z square k bar. That is I bar dot I bar 1 dou by dou x of y is the first term. Remaining I bar dot j bar 0, j bar dot k bar 0, I bar dot k bar 0. Similarly, j bar dot j bar 1 dou by dou y of x plus dou by dou z of z square. So this is 0, this is 0, this is 2z. Div f bar is 2z. Curly f bar means del cross f bar. Curly f bar is equal to del cross f bar and divergence of f bar is equal to del dot f bar. Right. So div f bar, what you will get is the value is 2z. The value is 2z. Now apply the Green's theorem. What is it? Sorry, Gauss divergence theorem. By Gauss divergence theorem, integral over this value is equal to, we have to evaluate this one. This value is equal to integral over v div f bar. Now, by Gauss divergence theorem, integral f bar dot ds bar is equal to integral div f bar dv. Div f bar dv. Already here I have clearly mentioned. That is triple integral. What is f bar? Div f bar 2z and here dx, dy and dz. So z limit is a constant limit. Z is equal to from a to b. Already mentioned. Z is a height limit. Z is a to z is equal to 0 to z is equal to b. Not a to b. Z is equal to 0 to z is equal to b. So finally we will do this. Next, volume. How to find the volume limits? Here I will write. So the volume is nothing but length into breadth into height. Volume is nothing but length into breadth into height. Already the height limit z varies from 0 to b. Now on considering the area of the circle x square plus y square is equal to a square. Now the limits for integration x square plus y square is equal to a square limits. Here I am considering the strip inside the region. Y varies from minus square root of a square minus x square to plus square root of a square minus x square. The strip limit y from minus to plus. But x varies from minus a to plus e. X varies from minus a to plus e. Now I am substituting the limit. X is minus a to a. Y is minus root of a square minus x square to plus square root of a square minus x square. Plus square root of a square minus x square. This is integral 0 to b z limit. X limit 0 to a. Y limit minus square root of a square minus x square to plus square root of a square minus x square. Function 2z into dz, dy, dx, dz. So integrating 0 to b constant limit, 0 to a constant limit. With respect to y integration, integral 2z constant term when we are integrating with respect to y will come. It is minus square root of a square minus x square to plus square root of a square minus x square dx into dz. So this is 0 to b z limit, x limit 0 to a, 2 constant. I can write 2 outside. This is upper limit. Integral dy is y. So what is the root a square minus x square minus of minus plus 2 root a square minus x square of dx into dz. This is 2 into integral 0 to b, integral 0 to a. So it is upper limit. So 2 root, this summation 2 into root of a square minus x square dx into dz. So this is 2 into integral 0 to b, integral 0 to a, 4 into root of a square minus x square dx into dz. This is z limit and this is x limit. So you can solve this value by using x is equal to a sin theta. On putting x a sin theta, dx is equal to a cos theta d theta, and this is 4 into integral 0 to b square root of, on putting integration, x is 0 to 1, new limits, theta limits 0 to 1, these are the z limits. When x is 0, a sin theta 0, sin theta 0, theta 0. When theta is equal to a, sin theta is equal to 1, theta is equal to pi by 2. And here a square minus x means a square sin square theta dx into dz. So what you will get is 4 into integral 0 to b, integral 0 to pi by 2, and it is root of a square minus a square sin square, a square into 1 minus sin square, a square cos square. I am writing outside a cos theta dx into d theta into dz. This is d theta dz. So 4a into integral 0 to b cos theta integration sin theta 0 to pi by 2 dz. That is 4a into integral 0 to a sin 91 sin 0 0. So 1 into dz, or 4 into a into z between 0 and a, or that is 4a square. So the value is equal to 4a square, which is by using the Gauss divergence theorem. Integral f bar dot ds bar is equal to, or f bar dot ds, or you can write the same thing as f bar dot n bar into ds. This value is equal to, by Gauss divergence theorem, integral div f bar dv. Div f bar means, or calculating you will get 2z, dv means dx into dy into dz. So the limits has to be considered, the base is circle limit and the height limit is from 0 to z. So in this way we can calculate the double integral and triple integral, and this problems has been taken from the question bank of the course Differential Equations and Vector Calculus of BT 23 published by IARE, and in the next video I will go to the same module B section, B part. Please go through it also. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.